Hello student, good morning. I am Dr. Ajay Kumar Sinha, Professor of Chemistry. Today I will continue from the last class. Last class I have discussed a neurologically active drug. Under that I have discussed tranquilizers, analgesics and antibiotics. Now under the antibiotics I was discussing penicillin and that I have also discussed about the this bactericidal and bacteriostatic antibiotics. I will continue only from here. Antibiotics have either cidal effect, also called killing effect, or a static effect, means inhibitory effect on microbes. A few examples of two types of antibiotics I am telling you now. First, bactericidal. Under that, what are the examples of bactericidal? Then first is the penicillin. Second is aminoglycosides. Third is ofloxacin. And under this bacteriostatic, under that example I am telling you, first is erythromycin, second is tetracycline, and third is chloramphenicol. The range of bacteria or other microorganisms that are affected by a certain antibiotics is expressed as its spectrum of action. Antibiotics which kill or inhibit a wide range of gram-positive and gram-negative bacteria are said to be broad-spectrum antibiotics. Those effective mainly against gram-positive or gram-negative, any one, gram-positive or gram-negative bacteria are narrow-spectrum antibiotics. If effective against a single organism or disease, they are referred to as limited spectrum antibiotics. Penicillin G has a narrow spectrum. Ampicillin and amoxicillin are synthetic modification of penicillins. These have broad spectrum. It is absolutely essential to test the patients for sensitivity, means allergy test, to penicillin before it is administered. This is very important point. It is absolutely essential to test the patients for sensitivity to penicillin, means allergy test to penicillin before it is administered. Okay, and where it is produced? Then penicillin is manufactured at the Hindustan Antibiotics in Pimpri and in private sector industry. Chloramphenicol. Now I will tell more about chloramphenicol. Chloramphenicol, isolated in 1947, is a broad spectrum antibiotic. You remember, question is asked. Chloramphenicol is a broad spectrum antibiotics. It is rapidly absorbed from gastrointestinal tract. It is rapidly absorbed from the gastrointestinal tract and hence can be given orally in case of remember, first typhoid, second dysentery, third acute fever, fourth certain form of urinary infections, fifth meningitis, one disease there, meningitis, and seventh is pneumonia. Then in all this disease it is applied. Again I am telling you disease name because it is important. Okay. First where it is given orally, then it is given in case of typhoid, second dysentery, third acute fever, fourth certain form of urinary infection, and fifth meningitis, and seventh pneumonia. Now another antibiotic I am telling you, vancomycin, vancomycin, VANCO, mycin, MYCIN, vancomycin, and other is ofloxacin. Ofloxacin. These two drugs are the other important broad spectrum antibiotics. Remember, that is the vancomycin and ofloxacin. These two are the other important broad spectrum antibiotics. The antibiotics diphenhydramine, third one next time talking about, that is the antibiotics diphenhydramine is supposed to be toxic towards certain strains cancer cell. You remember, this is used in cancer cell also, in cancer. This that is the diphenhydramine. Remember, diphenhydramine is supposed to be toxic towards certain strains of cancer cell. Okay, and there's a structure you can see, penicillin structure. You can in diagram I will send, that time you can see it is also complicated structure, that is of penicillin and chloramphenicol. That structure also I will send it diagram. That is a structure, not the diagram, chemical structure. All are just complex structure, and in this you will find in this structure 4-membered ring, 5-membered ring, 4 atoms will be there, 4-membered rings, 5 members ring. In that ring carboxylic acid, methyl group, and RCONH group will be attached, and in 5-membered ring sulfur and nitrogen will be there. In 4 and 5, in 4 and 5, in 5 sulfur and N both will be there, and in 4-member N will be there, nitrogen, and sulfur and N both will be present in 5-membered ring, and both rings are attached to itself. Both are attached to itself, and in chloramphenicol, one benzene ring will be there, and with that benzene ring at alpha position and para position certain group is attached, means para position NO2 is attached, and at alpha position long chain group is attached. That is, in that you can tell 3 carbon straight line, 3 carbon straight line chain is attached. In that first carbon OH is attached, and in second carbon NHCO CHCl2 is attached, and third carbon, that in the state chain, third carbon OH is attached. Okay, after seeing you can understand, after if you see the chemical structure easily you can understand. Okay, now I am going to discuss antiseptics and disinfectants. Antiseptics and disinfectants. Antiseptics and disinfectants are also the chemicals which either kill or prevent the growth of microorganisms. Antiseptics are applied to the living tissues such as wounds, cuts, ulcers, and diseased skin surface. Okay, again you remember, antiseptics are applied to the living tissues such as wounds, cuts, ulcers, and diseased skin surfaces. Examples are furacin. Antiseptic examples are, you should remember, some common example you should remember being a student of chemistry. Then their examples are furacin. Second is soframycin, SOFRA, sofra, mycin, MICIN. These two you remember, these are common. Furacin, soframycin. These are not ingested like antibiotics. You can't ingest it. Okay, these are not ingested like antibiotics. Commonly used antiseptics, that is, you might be knowing, Dettol. Commonly used antiseptic, Dettol. What is the Dettol? You remember, because daily in your home you are using Dettol in various form. Then Dettol is a mixture of chloroxy, xylenol, chlorxylenol, that is mixture of chlorxylenol and terpenol. It is a mixture of two, chlorxylenol and terpenol. It is a mixture of this terpenol and chlorxylenol. Okay, and bethionol, that is the compound, is also the compound is also called bethonol. Bethonol, OL, bethonol is also called bethionol, AL, aldehyde. And bethionol, OL, alcohol is there. Then this is also called, the compound is bethionol. This compound is also called bethionol. This is added to soaps to impart antiseptic properties. In some soaps, antiseptic properties will be there. Then in that soap, bethionol is added. Bethionol is added to soaps to impart antiseptic properties. Iodine is a powerful antiseptic. Remember, iodine solution. Iodine is a powerful antiseptic. Its 2-3% solution in alcohol water mixture is known as tincture of iodine. It is a common antibiotics. Okay, very common. In a village, generally, this doctor will give to so many, you can say, patient only this, because it is cheaper. It is cheaper antibiotics. Okay. Then not antiseptic, not antibiotics, antiseptic. Okay. Then this iodine is a powerful antiseptic. It's a 2-3% solution in alcohol water mixture. You will take just 2 gram, between 2 to 3 gram you take iodine and dissolve in alcohol water mixture. Then that solution is known as tincture iodine. Its color will be blue color like that. Okay, like blue, dark blue sometimes. It is applied on wounds. Okay, iodoform is also used as an antiseptic for wounds. Iodoform. Okay, here also iodine is there. Just like a chloroform is there, CHCl3. Then in the place of Cl3, I3 will be there. CHCl3 is a chloroform. In the place of Cl, if iodine will come I, then CHI3 will be called iodoform. Then iodoform is also used as an antiseptic for wounds. Now next, boric acid. Boric acid in a dilute aqueous solution is weak antiseptic for eyes. Boric acid powder in carom board, you are using that powder, that is boric acid, white color powder. Boric acid in dilute aqueous solution, if you dissolve in water means distilled water, then that is called boric acid aqueous solution. It should be dilute, not in more quantity. Then it can be used for eyes also. Boric acid in dilute aqueous solution, dilute, not concentrated. Boric acid in dilute aqueous solution is weak antiseptic for eyes. Now I will send the structure of all these. Okay, you can understand. This chlorgelinol, it is very simple structure. Means for Dettol, it is a mixture of two terpineol and chlorogelinol. Then chlorogelinol, this gelinol structure is simple. Means in benzene, now actually ortho and para position. At ortho position OH is attached and at para position Cl is attached. And left and right side of Cl, methyl group is attached. Correct? Again I am telling you, it is easy. Benzene ring is there. Then at ortho position OH is there. At para position Cl is there. And left and right CH3 group is attached. Left and right of Cl. Left and right of Cl means at meta position CH3 is attached to CH3. Each one is the left side, other is the right side. Both are at meta position. And this is the chlorogelinol. Okay. And terpineol, its structure is that benzene ring is there, but in that benzene ring only one double bond is there inside. Okay. And at near the ortho position only one first and second only there, carbon 1 and carbon 2 double bond is there, everywhere single bond in the ring. And at ortho position CH3 is there. And at para position you can understand that carbon is attached from the para position separate, and that carbon has two CH3 group attached and one OH group is attached. Understood? In benzene ring is attached with a carbon having two CH3 and one OH group. This is the terpineol. And what is actually this bithionol, then which is added in soap. Then here two benzene structure is joined together through S. Sulfur is there, then sulfur is in the middle, one side one ring, benzene ring, other side another benzene ring. Sulfur has two valency, then one side one benzene ring, other side other benzene ring. Correct? And that benzene ring Now you should understand 3 groups are attached in that benzene ring. Means here alternate double bond and single bond is there like a benzene only. Then here means where sulfur is attached, from that carbon next to that carbon where sulfur is attached, next to that carbon OH is attached, and next to OH carbon where OH is attached, from that carbon Cl is attached, and after that leaving one carbon, next carbon again Cl is attached. Means 2 Cl is attached, 2 Cl is attached and 1 OH is attached. Okay, then this 2 Cl is attached, then between the 2 Cl where it is at that one carbon nothing nothing is attached. Means Cl is attached, next carbon nothing is attached, after that next carbon Cl is attached. Okay, then same things happens here with another ring. Left side ring I told you, right side same things. That is the carbon through which sulfur is attached, or sulfur to which carbon is attached. Next to that carbon OH is attached, and next to that OH Cl is attached. Again one carbon is there, leaving that carbon nothing is attached, next to that carbon Cl is attached. Means same copy, left and right. This is the butanol structure. Now I am discussing disinfectants. Disinfectants are applied to where it is applied to, it is applied to inanimate objects such as floors, drainage system, instruments, etc. You have seen also sometimes that in drainage some powder like a bleaching powder what you are telling, other these chemicals, that is actually that is also disinfectant only. Then these disinfectants are applied to inanimate objects such as floors, drainage system, instruments, etc. Same substances can act as an antiseptic. This will function as an antiseptic as well as disinfectant also by varying the concentration. You remember, same substances can be act as an antiseptic as well as a disinfectant by varying concentration. For example, 0.2% solution of phenol is an antiseptic, 0.2, while it's a 1% solution, it is a 0.2%, very less. But when concentration is more, means 1% solution, means more concentrated, that is called, that will function as disinfectant. Okay, 0.2% solution of phenol is an antiseptic, and 1% phenol function as a disinfectant. Chlorine, second example, chlorine in the concentration of 0.2 to 0.4, between that 0.2 to 0.4 ppm parts per million in aqueous solution, and sulfur dioxide in very low concentrations are disinfectants. You remember, these are the examples. Chlorine, you will get from where you will get chlorine, then that is from bleaching powder, in that chlorine will be there. That's why it is just where drainage there it is thrown. Okay, chlorine is chlorine in the concentration of 0.2 to 0.4 ppm in aqueous solution, and other is SO2. Sulfur dioxide in very low concentrations are disinfectants. Now I am going to tell about another important drugs, that is the anti-fertility drugs. You might be knowing also anti-fertility drugs to control the birth. Antibiotic revolution has provided long and healthy life to people. The life expectancy has almost doubled. The increased population has caused many social problems in terms of food resources, environmental issues, employment, etc. To control these problems, population is required to be controlled. This has led to the concept of family planning. Anti-fertility drugs are of use in this direction. Birth control pills essentially contain a mixture of synthetic estrogen and progesterone derivative. First is a synthetic estrogen, and second is progesterone. Both are estrone. One is synthetic estrone and other is progesterone derivatives. Both of these compounds are hormones. It is known that progesterone successive, how it works I am telling you. It is known that this progesterone suppresses ovulation. Synthetic progesterone derivatives are more potent than progesterone. Synthetic progesterone is progesterone is derivative I am talking about. Synthetic progesterone derivatives are more potent, powerful than progesterone. Okay, and another is northindrone. Northindrone is an example of synthetic progesterone. Northindrone is an example of synthetic progesterone. Okay, that is a derivative of progesterone, and it is most widely used as a anti-fertility drug. Again, you remember northindrone, N-O-R-E, northindrone, T-H-I-N-D-R-O-N-E. Northindrone is an example of synthetic progesterone derivative, most widely used as a anti-fertility drug. The estrogen derivatives, which is used in combination with progesterone derivatives, is ethinyl estradiol. Okay, remember, combination of both. The estrogen derivative, which is used in combination with progesterone derivative, is ethinyl estradiol. Ethinyl estradiol, also known as novestrol, Novestrol, novestrol. Okay. Now I am going to discuss chemicals in food. Chemicals in food, these are very, very important. Okay. Question is asked. Which chemicals is used in food? Chemicals in food. Chemicals are added to food for their some purpose. First purpose is for their preservation, and second, enhancing their appeal, and third, adding nutritive value in them. Okay, why chemicals are added in food? Then there are three reasons. First, for their preservation. Second, enhancing their appeal. And third, adding nutritive value in them. Main categories of food additives are, I am telling now. First is food colors. Food color, these are the additives. Food color, if you want some special color, then for that purpose additives are used. Then first is food colors. Okay, these are the additives, food additives. Second is flavors and sweeteners. Flavors, to get the flavors and sweet in taste, then that is added. That is called, this additive is called flavors and sweeteners. Third, fat emulsifier and stabilizing agents. Fat emulsifier and stabilizing agents. Fourth, flour improvers. Flour improvers, anti-stalling agents and bleachage. For that, this is also additive. Flour improvers. Flour improvers means here anti-stalling agents. Generally food will stale. Then to preserve the food, anti-stalling agents are used. Okay, flour that is as a our concept for the flour improvers like anti-stalling agents and bleachage. And next, that is the fifth one, that is the antioxidant. And sixth one, as a preservative. This time additives are known as preservatives. And seventh, that is the nutritional supplements such as minerals, vitamins and amino acid. These are added to the food. Then all I have discussed, seven I have discussed, these are the additives and is used in food. First is the food colors, second is flavors and sweeteners, third is the fat emulsifier and stabilizing agents, and fourth is flour improvers, as for example anti-stalling agents and bleachage, and fifth one is antioxidant, sixth one is preservative, and seventh one nutritional supplements such as minerals, vitamins and amino acid. Now this except for chemicals of category means the last category, seventh, none of the above additive you can say have a nutritive value. You remember, except for chemicals category 7 means last what I discussed, nutritional supplements like minerals, vitamins, amino acid. This is an exception. These have some nutritive value, but others have no. Other 6 have no nutritive value. We remember, question is asked. Except for chemicals of category 7 means minerals, vitamins and amino acids. Except these additives, all six what I told you, except for chemicals this nutritional supplements, minerals, vitamins, and amino acids. Okay, these are the exception. None of the above additives, means first 6, have nutritive value. First 6 have no nutritive value. None of the above additive have nutritive value. Only minerals, vitamins, and amino acid have nutritive value. Okay, that means food color, no nutritive value; flavors, no nutritive value; fat emulsifiers, no nutritive value; flour improvers, no nutritive value; antioxidant, no nutritive value; preservatives, no nutritive value. Only minerals, vitamins, amino acids, they have nutritional value. Okay. Now this I will tell more about the artificial sweetening. Okay, artificial sweetening agents. Artificial sweetening agents also, I told you, have no nutritional value. Very first important point. Natural sweeteners, as for example sucrose, add to a caloric intake. Sucrose, glucose, fructose, these are the main staple, main food for us. They give nutrition, caloric value. You will get energy. Okay. Natural sweeteners, they are in sweet sugar, ordinary sugar, which is called sucrose. Sucrose, even the glucose also, fructose also. Sucrose add to caloric intake, and therefore many people prefer to use artificial sweeteners. For diabetic person, they don't want, or fatty person who are very fatty, they don't want, you can say, too much carbohydrate. Then to control that fat, what they will do? Correct? They supply, you can say, energy, fat. They actually only from the carbohydrate fat is formed. Then just to control purpose, fatty person want to reduce the fat. That time they don't want sucrose. Correct? Sucrose. Then but they want some sweetness. Then that's why artificial sweeteners are required. Natural sweeteners, as for example sucrose, add to a calorific value, caloric intake, and therefore many people prefer to use artificial sweeteners. Just remember the name, orthosulfobenzimide. Orthosulfobenzimide, also called saccharin. You might have heard the name saccharin. Its chemical name is orthosulfobenzimide. Is the first popular artificial sweetening agent. It has been used as a sweetening agent ever since it was discovered in 1879. Okay, since 1879 people are using. It is about, now you just, if you compare with sugar, how much sweetness is there, then it is about 555 times as sweet as cane sugar. Ordinary sugar means 1 spoon ordinary sugar. 1 spoon, 100, just 550 spoon ordinary sugar. Sweetness is equal to 1 spoon saccharin. You remember like that. 550 times this saccharin is 550 times more sweet than sucrose, means ordinary sugar. Okay, it is about 550 times as sweet as cane sugar. It is excreted from the body. How we will get this saccharin? Then it is excreted from the body in urine. And one more thing here, important things. this saccharin, if we will take, if we will use, then it will come out through urine without change. Without change, without any reaction, it will come out through urine. Okay. This you remember, that it is excreted from the body in urine unchanged. It appears to be entirely inert, no reaction. It appears to be entirely inert and harmless when taken. But here harmless is there when you are taking less quantity, very less quantity. But many this artificial sweetenings are toxic also. Excess of everything is bad. Then it actually it is coming under harmless, but if you will take regularly you will take, then it may prove toxic also. And so every time you should not use, and you should not take it in a more quantity. Just to change the taste, you can use it. Okay. Then it is 90% harmless, but you will take more, then it can prove toxic also. Its use is of great value to diabetic persons and people who need to control intake of calories. Okay. Some commonly marketed artificial sweeteners, I will tell the example. First example which is commonly used and it is available in market, that is the first sweetener is artificial sweetener is aspartame. You remember aspartame, TAME, aspartame. It is 100 times more you can say sweet than sugar. 100 times more sweet than sugar, and it has actually aspartame. This sweetener molecule, if you will see a structure, if you will see, then it is a long structure and it has two parts. This structure can be divided into two parts. First part is aspartic acid. Actually name itself is there, aspartame. Aspar, ASPR, aspartic acid. From that this word came aspar, and other is tame, TAME. Then now here this structure is divided, a long structure is there. Then it is divided into two parts. First is aspartic acid part, and second is phenylalanine methyl ester part. Correct? And it's, I told you, sweetness 100 times more sweet than sucrose. Second example I am telling you, that is a saccharin. Already told you its structure is a simple structure. Simple structure means two ring is there. One ring is benzene, and other ring is this you can tell 1, 2, 3, 5-member ring. This is 2, 3, 4, 5. 5-member. One is a 6-member ring, other is 5-member ring. Both are attached, and that only from the benzene ring one you can say other ring is attached, and in that 5 ring means when it is that attached with the benzene ring, then next to the benzene ring carbon, in another ring, that is the carbon, with that carbon O is attached, CO, means this carbon is attached with the CO. Benzene ring carbon is attached with the CO, and that CO, that C is attached with NH, and NH is attached with SO2, SO2, and that SO2 is again attached with carbon. Okay, then carbon you can understand like that, carbon number 1 and carbon number 2, carbon number and carbon number 2, one that is with carbon number 1 CO is attached, and with CO means with C carbon NH is attached, and NH is attached with SO2, and SO2 is attached with second carbon of benzene. Okay, with the first carbon CO is attached, with second carbon SO2 is attached. Okay, and between the CO and SO2 NH is there. That NH is attached with one side with CO, other side with SO2, means sulfur. Okay, and saccharin already told you it is a 550 times more sweeter than sucrose, 550 times more sweet than cane sugar or sucrose. And now this third one I am telling you, sucralose. Sucralose. It is again long structure, very long structure, and it is 600 times more sweeter than sucrose, means cane sugar. Standard you have considered as a cane sugar. In comparison to the cane sugar, this is 600 times more sweeter. Okay, that is sucralose, and its structure is complicated. Here also that chair form, chair form is there, and another form is also there, 5-membered ring is there, that is there. Okay, I will send the structure, and it is 600 this things times more sweeter than cane sugar or sucrose. And one more I want to tell you, that is the elitame. This is always you remember, 2000 times more sweeter than sucrose. 2000. See, means 1 spoon of ultimate is equal to 2000 spoon of sucrose. 2000, correct, in 2000 times more sweeter than sucrose, and its structure is also long. Okay, I will try to send it. This is actually elitame. You remember elitame. Okay, then this I have discussed about this artificial sweetening agent, and more about aspartame. Already I told you, aspartame is the most successful and widely used artificial sweetener. It is roughly, you can tell, already told you, roughly 100 times as sweet as cane sugar. It is a methyl ester of dipeptide formed from aspartic acid and phenylalanine. Okay, you remember about the aspartame. It is a methyl ester, it is a ester of dipeptide. It is the ester of dipeptide formed from aspartic acid and phenylalanine. Use of aspartame is limited to cold foods. You remember, it is used in cold food. Then now you remember what is the cold food you are using, just to think. Then it is a soft drink, cold drink. There it is used. You remember, there they will not use sucrose. They will use here aspartame. Aspartame is limited to cold foods and soft drinks. because it is unstable at cooking temperature. At high temperature, it is a long chain compound, it will break at high temperature. That's why it is used in a less temperature, cold food and soft drinks, because it is unstable at a cooking temperature. Now about the Chem. Chem is highly potency sweetener, although it is more stable than aspartame. The control of sweetness of food is difficult while using it. You remember, the control of sweetness of food is difficult while using it. Should use it in a very less quantity, because it is very more, I told you 600 times. Correct? This 550 times, and the control of sweetness of food is difficult while using it. And that is the sucralose. Then sucralose is trichloro derivative of sucrose. Sucralose is a trichloro derivative of sucrose. Its appearance and taste are like sugar. It is also stable at cooking temperature. It does not provide calories. All this artificial and not artificial sweeteners are, you can say, this non-calorific, means it will not give caloric value will be 0. Correct? No caloric value is 0. Okay. Then this I have told you about these things, artificial sweetening agent. Now just I want to tell about the preservatives. You might be knowing also. If you are not knowing, then you remember it. Okay. Food preservatives prevent spoilage of food due to microbial growth. The most commonly used preservatives include table salt. Salt is also used as a preservative, table salt, NaCl. Second, sugar is also used as preservative. Third is vegetable oils. Sometimes oil also is used to preserve. Correct? And next is sodium benzoate. Actually in grains generally, rice and this sometimes rice and wheat or any other grains, there they will use sodium benzoate. Then these are I told you preservative: salt, sugar, vegetable oils and sodium benzoate. Sodium benzoate is used in limited quantities, very less, and is metabolized in the body. That's why it is used in less quantity, because it will do, this will react with the body. Sodium benzoate is used in a limited quantities and is metabolized in the body. Salts of sorbic acid, again I am telling you, salts of sorbic acid and propanoic acids are also used as preservative. All questions are asked in examination. They will tell option, they will give. In that one correct they will write preservative, and they will ask which are the preservative. Okay. Hence you should remember that is salts of sorbic acid and salts of propanoic acid. These are also preservative, and sodium benzoate already I have told you. Okay. Then today I am stopping only here. Next class I will continue with other terms. Okay. Thank you.